an A, because they're in the 90s above grades range. L if the score is greater than or equal to 80, and the score is less than or equal to, say, 89. But here I have some options. Logically, I can actually express myself in any number of ways. And maybe just to be a little cleaner, I'm going to say a score is less than 90. So I'm using less than instead of less than or equal to. So I'm making sure that their boundaries between these grades are correct. Then I'm going to go ahead and give the student a B if it's in the 80s. L if score is greater than or equal to 70 and the score is less than 80, I'm going to go ahead and give them a C. L if the score is greater than or equal to 60 and the score is less than 70, I'm going to go ahead and give them a D. And here's where it's a little anomalous, at least in some schools here. Else, I'm going to go ahead and give them an F. So we're skipping E altogether, and we're going to give an F instead for the grade. So that's the catch-all. And I think logically I've gotten this correct, at least based on where I went to school growing up, such that it's going to give an A or a B or a C or a D. Else, it's going to assume that you got an F. Well, let's try just a few of these here. Let's run python of grade.py. My score is, let's start strong, 100. All right, I got an A. Didn't do as well the next time. Maybe it's a 95. Still an A. Starting to slip further, so I got an 89 the next time. That's now, say, a B. And let's say I really had a bad week and it's now like a 71. That's now a C. Or I didn't even submit it at all. That's an F altogether. All right, so it seems to work. That's not really an exhaustive test, but at least based on some sampling there, my code seems to work as I expect. But let's see if we can't tighten this up. It's not wrong. It's correct. And indeed, according to my own specifications, I dare say this code is correct. But can we tighten it up? Can we reduce the probability of bugs now or down the line? Can we increase the readability of it? And can we increase the efficiency of it? Can we get the computer to have to answer fewer questions and still get the same result? Well, let's see what we might do. Let me just kind of switch things up, if only to demonstrate that we can use these symbols in different ways. I could say, as I've done, if score is greater than or equal to 90. But I can actually do this. I can flip it around. Instead of saying greater than or equal to, let's say 90 is less than or equal to score. And here, let's say if 80 is less than or equal to score, and here 70 is less than or equal to score, and then lastly 60 is less than or equal to score. So it's the same thing logically. I'm just kind of switching things around, just like you could do on paper pencil if you really wanted. But now notice this trick, and this is not possible for those of you who have programmed in C or C++ or Java or other languages. Notice what I can do here is actually combine these ranges. Notice that I'm asking two questions, two Boolean expressions. Is 90 less than or equal to score, and is score less than or equal to 100? Well, Python allows you to nest these things like this and chain them together. And just like you would on paper pencil in the real world, you can encode in Python do this, which is just a little cleaner, right? It's tightening up the code a little bit. It's fewer keystrokes. It's faster to type. It's easier to read moving forward. So that's arguably better as well. So that's one improvement. It's largely aesthetic in this case. It's still asking the same number of questions, but it's doing it a little more succinctly still. Well, what more could I do here next? Well, you know what? Each time I'm deciding these grades, I don't think I have to ask two questions. I don't have to ask, is it greater than 90 and less than 100? Is it greater than 80 and less than 90? If I kind of rethink my logic, I can maybe do this better still. Let me propose that we simplify this further and just do this. If we know the input for the moment, is going to be within 0 and 100, we can make some assumptions. We could say something like, if the score is greater than or equal to 90, well, the student gets an A. If the score is greater than or equal to 80, the student gets a B. If score is greater than or equal to 70, they get a C. If the score is greater than or equal to 60, they get a D. Else, they get an F. So what have I done here? Well, instead of asking 2 questions every time, checking the lower bound and the upper bound of that range, I'm kind of being a little more clever here by asking, if the score is greater than 90, well, they've obviously gotten an A or better. If your score is greater than 80, well, you either deserve an A if it's really strong, or a B if it's just above 80. But because of the if logic, we've already checked, is the student's score greater than 90? And if it's not, then we're asking the question, well, is it greater than 80? So you implicitly know it's somewhere in the 80 to 89 range. Else, you know it's in the 70 to 79 range. Else, it's in the next range down. So it's a minor optimization that allows us to ask fewer questions. But again, it's making the code arguably a little more readable, certainly more succinct, and then hopefully more maintainable longer term. Any questions then on these types of changes and this type of logic with our code?
What if we don't use elif at all? What if we write the code in F?
Yeah, so that's a good question, because it's actually going to have an unintended effect here. Let me get rid of the F temporarily and just focus on A through D. If we revert to where we began today's story with conditional, saying if, now our cleverness here of using broader strokes and not using an upper and lower bound ranges is going to come back to be a downside. Let me go ahead and run python of grade.py, and suppose my score is 95. I am so darn excited. I want my A, but nope, I just got an A, a B, a C, and a D. So logically, that's broken things, because if you don't make these conditions mutually exclusive, every one of those questions is going to get asked and therefore answered. And even if your grade is above a 90, it's also logically above an 80, above a 70, above a 60. And if I'd kept it in there, I would have failed as well with an F. Really good question. Other questions here on this form of logic?
Like, would there be any, I guess, better way to kind of clean up even just this simple statement like we had before, the previous one that you had with the else if?
Oh, I like your enthusiasm for simplifying things further. I'm going to go out on a limb here and say this is about as good as it gets, at least using only conditional statements. I can, if my mind wanders, think of a slightly more clever way to do this, maybe with something called a loop or another programming construct. We don't have that yet in our vocabulary, but yes, there's absolutely other ways to do it, but I think not yet if we want to restrict ourselves to just words like if and or and else and elif and the like. Well, let me propose that we pivot now to use another approach here that uses one other symbol that up until now we've not really had occasion to use. Let me propose that we implement a program that we'll call parity. In mathematics, parity can refer to whether a number is even or odd. And that's kind of an interesting question, and it turns out it can be useful in other applications too. So I just ask the question, is a given number even or odd? Maybe that the user typed in. And let me go ahead and write a new program called parity.py via code parity.py in my terminal. And let me propose that we use this as an opportunity to introduce the last of those arithmetic symbols, at least most of which we're familiar with: addition, subtraction, multiplication, division. But there's been on this list before this last one here, a percent sign. And it doesn't mean percentage in this case when used as an operator in programming in Python. Rather, it represents the so-called modulo operator for modular arithmetic, or at least in our case, we're going to use it to calculate the remainder when dividing one number by another. Well, what do I mean by that? Well, if you take a number like 1 divided by 3, 3 does not go into 1 cleanly, so you have a remainder of 1. 2 divided by 3 has a remainder of 2. 3 divided by 3 has a remainder of 0, because it divides cleanly. 4 divided by 3 has a remainder of 1, because you can divide it in once, but then that leaves 1, so it has a remainder of 1. And then lastly, something like 5 divided by 3 has a remainder, of course, of 2. So that's all we mean by remainder, how much is left over after dividing one number by another. Well, if I go back now to my code and I consider how I might implement the question, is this number even or odd? Let's consider how we might implement that, since it's perhaps not necessarily obvious how we can use this additional building block, but it turns out it's going to be very useful longer term. Well, let's first just get a number from the user in a variable called x, and I'm going to set that equal to the conversion to int of whatever the user inputs after asking them, what's x question mark? And we've done that before many times. How do I now determine if x is even or odd? Well, it turns out if I have access to a programmatic operator that tells me the remainder, I think I can do this. In fact, let me just ask the group, and this is just from grade school math perhaps, what does it mean for a number number to be even, to be clear. A number like 0, 2, 4, 6, 8, 10, 12, 14, 16. Those are all even numbers, but what does that really mean? Elena, if I'm saying that right?
Even numbers that can divide it exactly by 2. For example, 2, 4, 6, 8, and 10. And
Perfect. And we could go on all day long, literally. So there's an infinite number of those even numbers, but it's nice that you formulated it in terms of a question that we can ask very clearly. Is this number cleanly divided by 2? That is, can we divide it by 2 with no remainder, a remainder of 0? Well, that's perfect, because if we have this operator, this percent sign, that allows us to answer just that, what is the remainder, we can presumably check, is the remainder 0 or is it 1? Do we have nothing left over or do we have 1 left over? Well, let's ask that. If x divided by 2 has a remainder of 0, as Elena proposes, let's go ahead and print out something like quote unquote even and just say as much to the user. Else, I think we can assume that if a number is not even, it's going to be odd if it's indeed an integer. So I'm going to go ahead and print out quote unquote odd instead. And let's go ahead and now run python of parity.py in my prompt. What's x? Let's start with 2. 2 is in fact even. Let's start with 4. 4 is in fact even. Let's get interesting with 3. 3 is now odd. And I think we could do do that all day long and hopefully get back indeed exactly that answer. But what more could we do here? How could we improve upon this? Well, recall that we have the ability to invent our own functions. And let me just propose for the sake of discussion that we're going to eventually find that it's useful to be able to determine if a number is even or odd. And so we'd like to have that functionality built in. And I don't think Python has a function for telling me just that, but I can invent it using code like just this. So let me go into my earlier version here, and let me propose that we do this. Let me go ahead and write a main function. I'm going to get back into that habit of defining a main function to represent the main part of my program, and I'm going to do what I did before. I'm going to get an integer from the user's input, asking them what's x, question mark, and then I'm going to ask this question. For the moment, I'm going to naively assume that the function already exists, but that's a useful problem-solving technique. Even if I have no idea yet where I'm going with this, how I'm going to invent a function that determines if a number is even, I'm just going to assume that there's a function called isEven, and I'm going to call it blindly like this. If isEven, passing in x, then go ahead and print quote unquote even. So if this magical function called isEven returns true as its return value, I'm going to print out that it's even. Else, otherwise, I'm going to assume that it's, of course, odd. Now, the one problem with this program, even if I call main over here, is that isEven does not exist. And this program would break if I ran it right now. But that's OK. I have the ability, recall, to invent my own function. So let me define with def a function called isEven. I want this function to take an argument, and I'm going to call it n, just a number, generically. I could call it x, but again, I don't want to confuse myself as to which x is which, so I'm going to give it a different name, and that's fine. I'm just going to call it more generically n for number. And then I'm going to do this. I'm going to say if n %2 equals 0, just like before, then, and here's the magic, you, the programmer, can actually return what are called Boolean values. We've seen in Python that Python has strs or strings, ints or integers, floats or floating point values, all of which are different types of data in Python. Python also has a fourth data type called bool for a Boolean value. And even though this is just adding to our list, the nice thing about bools is that they can only be true or false. An int can be any number of infinite possible values. A bool can only be true or false. And it must be capital T and capital F if you're writing itself. So if I go back now to my code and I consider exactly what I want to return here, well, if n %2 equals 0, that is, if n divided by 2 has a remainder of 0, well, I think it's even to, Elena, your definition, so let's return true, capital T. Else, if it doesn't have a remainder of 0, I'm pretty sure mathematically it's got to have a remainder of 1, but it doesn't matter. I know it's not even, so I'm going to return false. And we return false instead, capital F. And now that we've defined both main and isEven, and I'm calling main at the bottom, I think I've got this right. Python of parity.py, enter. What's x? Let's try something simple like 2. And it's even. Let's do it again. What's x? How about 4? Even. Once more. What's x? How about 3? and it's odd. Now, what have I done here? I've just made the point that if I want to create my own function called isEven that answers this question for me, that I can now use in this program and heck, maybe future programs that I write, I now have a function that no one gave me, I gave myself, that I can use and reuse. And I can even perhaps share it with others. I'm using that function now on line 3 just to make a decision. I'm using a conditional up there. And my Boolean expression, something that's true or false, is going to be not something explicit like x less than y or y greater than x or the like. It's going to be a function call. I'm using a function as my Boolean expression, but that's OK because I know, because I wrote it, that that function isEven returns true or it returns false. And that's all I need in a conditional to make a decision to print even or print odd. So let me pause here to see if there's any questions now on how I've implemented isEven using this bool.
Hello, hi David. First of all, thank you for this wonderful class day before yesterday and today, sir. I have just one query, like based on my background of Java.